Hey all, I'm back in the workshop. I know it's been a couple seconds since my last video. My air conditioning went out in the workshop, so I had to deal with that. Some other things happened when I was working on this project. So all of the instruments that are mounted in this panel are servo based. All of them are things I found on Thingiverse and printed out and built. But mostly the purpose of this is to demonstrate the use of the servo multiplexer. This board here actually came with some servos that I ordered. It's capable of driving 16 servos. I have it hooked up to my power supply separately, and it's also hooked up to this mega board. It only uses 2 wires. It's I2C connection. You can also chain these together in multiple boards. I forget how many, but you can drive most likely more servos than you would ever want to drive by doing that. I just have one board hooked up right now. It looks like there's 9 servos, so these each have 2. So that's 2, 4, 6, 7, 8, 9. 9 servos are hooked up to this. The instruments that are missing here are probably not conducive to working well with servos. I'm just building this panel to demonstrate. And speaking of this panel, this came from a friend of mine. For you aviation buffs out there, you get bonus points if you can tell me what this panel is out of, but I'll give you a hint, as there's supposed to be more stuff in between. And also these are reversed. This is the pilot side over here, which I have turned around because it had bigger instruments in here. And this is the co-pilot side, which I turned around, which looked a little bit better for the purposes of this demonstration. Stay till the end of the video and I'll reveal what this is actually out of. If you have thoughts on it, go ahead and put them in the comments section. Anyway, let's get started. You can see the panel here is tracking the instruments pretty well. I've got the AI flying this. Let's make it do something here. RPM is tracking, vertical speed is tracking, airspeed is tracking. Turn coordinator is tracking all the instruments. I've got temperature and oil pressure that are tracking over there. Vacuum and ammeter is tracking. Make the AI fly it again. So anyway, this is all working pretty well. Here's the code for this. I added an add-on header for XPLPro called XPL MUX9685 servos. It depends on the Adafruit PWM library, so you'll need to install that as well. I'll provide this example on the Patreon page, also on Discord, also in the examples for the library when you update. Incidentally, with this you'll have to update because I've made some changes to the library. So it works by creating an instance of the servo bank. We'll start it up by telling it how to access XPLPro and also what the address is of the board that you have. And you can configure these boards by putting jumpers on to, I think, 16, something like that. Different. And they would be in order, so 40, 41, 42, so on. Nothing's changed in the loop. In the inbound handler, we send it out to check the servos. And that handles everything for you. In the register, we just find the data refs that we want. We request updates to those data refs. And then we set the scaling. Now on this servo multiplexer, I've decided to use microseconds instead of degrees because it's more consistent over the different manufacturers of the servos. I have updated my servo calibrating software to represent microseconds as well. I think I'm going to do a separate video on my servo calibration thing. This is the servo calibrator right here. So now I can press the button on here and get microseconds when you're tuning. So on here you set the scaling. For instance, this is the RPM. On the Cessna, the scale goes from 0 to 3,500, and I've got that in here on the scale. And then when I calibrated, I found that about 894 microseconds represented 0, and 2028 represented 3,500. So we scale it to that, and it looks pretty close. I do see a need for additional scale points on some instruments that are not linearly calibrated. So that's something I'll address pretty soon. We add the servo. This is the data ref that we're adding. This is the array element if it's an array type data ref. This is the servo number on the board, and this will increment. So this is 0, this is 1, and this is where we want it to go. I wanted it to go to 0 when we originally initiate the servo. And then we do that for each one, and that's really all there is to the code, and it just works. To answer the trivia question at the beginning of the video, this panel was taken out of a Cessna 425 Conquest for the purposes of a panel upgrade. But I want to thank Justin for letting me use this to have a place to mount these. I'll see you in the next video. I still need to finish the 737 MCP. We're just working on the lights. I've also been working on a Mac version of the plugin. My Mac programming skills are not the best, so there's a little learning curve, so be patient with me on that. I'll see you in the next video. Have an awesome day.